You're paying for water in more ways than most folks realize. You pay when the pump kicks on. You pay when the electric bill comes. You pay when the pressure tank starts acting up, when a switch burns out, when a line freezes, when a repairman has to drive all the way out to the farm, because the system you depend on has one more part that can fail. And all the while, there may be water on your own land, trying to make itself available for free. Not in theory. Not in some rare once-in-a-lifetime setup. I mean water most farmers walk right past because they do not recognize what they are looking at. A wet place on a slope. A patch of moss that never burns off. Ground that stays soft in August when everything else has gone hard. Most people call that poor drainage. In a lot of cases, what they are actually looking at is a spring. And if you know the old Amish engineering trick for capturing it, that wet patch can become a steady source of livestock water, without a pump, without a motor, and without a monthly bill following you around year after year. I'm going to walk you through exactly how that works. Because once you understand the principle, the whole system gets a lot simpler than most people think. And the reason I say $12 is not because I'm pretending the whole farm water system appears out of thin air for the price of a sandwich. I want to be plain about it. The heart of the trick, the part that turns a wet hillside into a usable gravity-fed source, can be put together for about $12 in basic fittings and patch material if you're using salvage block, scrap tin, or other common farm materials for the box itself. The delivery line downhill is its own cost, and I'll tell you that straight when we get there. But the engineering trick, the part that actually makes the spring work for you, instead of soaking uselessly into the ground, is cheap, old, and proven. I farm around people who still value a system that does not need electricity to deserve its place. And I can tell you, this is not a novelty method, and it is not the kind of idea that sounds good until weather changes. These spring box systems have watered livestock in hilly farm country for generations. Some of them were put in before a lot of places even had reliable rural power, and they are still working because the land is still doing what the land has always done. Water moves underground, pressure brings it to a seam, and gravity takes it downhill if you give it a clean path. That is the whole backbone of it. You are not creating water. You are not forcing it out of the ground. You are collecting what is already there and directing it where you need it. Most people miss the best natural water source on their property because they are waiting for something obvious. They expect a clear stream, a bubbling springhead, a place where water is announcing itself in a way nobody could mistake. But springs are often quieter than that. A good spring may show itself as a line of greener growth across a hillside. It may be a spot where sedges, moss, rushes, or other wet-loving plants keep thriving when the field around them is drying down. It may be a strip where the frost melts early, or where the soil stays cool and soft in late summer, or where livestock keep nosing around because they can feel moisture close to the surface. Folks look at those signs and think nuisance. What the old farmers knew was that those signs often point to pressurized groundwater, moving through a porous layer underground until it hits clay, shale, or another tighter layer it cannot pass through. At that point, the water is forced sideways and out. That is your spring seam. And here is the first thing you need to understand if you want the rest of this to make sense. The water is already under enough pressure to move. Your job is not to pump it. Your job is to intercept it before it spreads out, before it mixes with surface runoff, and before it turns into nothing more than a muddy wet spot people complain about. Once you see that clearly, the whole idea changes. You stop thinking like someone who needs to extract water with machinery, and you start thinking like someone who needs to catch and direct water that is already trying to leave the hillside on its own. Collection first, direction second. Gravity the rest of the way. That is the principle. And because the principle is so simple, people tend to underestimate how well it works. The first step is finding the spring properly. Late summer is the best time to do it, because that is when the property tells the truth. In spring, when the ground is saturated and every hollow is damp, half the farm can fool you. But in late August or early September, when things have tightened up and water levels are lower, the places that remain wet are the places worth your attention. Walk the hillsides and watch for patterns, not just puddles. A random soggy patch may only be runoff collecting in a bad spot. But if you see moisture holding in a line across a slope, especially where the vegetation changes noticeably from one strip of ground to the next, that is often the seam where the water-bearing layer meets the hard layer below it. Dig along that seam, and you are likely to find what the surface has only been hinting at. Now here is the part most people get wrong, and this is the mistake that separates a poor installation from one that will run for decades. They dig right where they see the water bubbling out on the surface. It feels like the obvious move. But the visible seep is usually not the best place to build your collection box. You want to go uphill from that visible seepage point, often 10 to 15 feet, sometimes a little more depending on the lay of the ground. The reason is simple. The water you see on the surface has already escaped the best collection zone. It has already spread out. It has already had a chance to pick up surface contamination and lose some of its force. If you intercept it uphill, before it opens up and fans out through the soil, you are catching it cleaner and earlier. That one decision changes the whole quality of the system. The collection box itself is not something you need to romanticize. It just needs to do its job. I have seen boxes built from concrete block, old chest freezers with the working parts stripped out, culvert sections, formed concrete, heavy timber lined properly, and all sorts of salvage a practical farm can lay hands on. The material is not the secret. The function is. The box has to collect water entering from the hillside, keep dirt out from the front and top, and give sediment a place to settle before the water enters your outlet line. For a small farm or ordinary livestock setup, a box around 3 feet long, 2 feet wide, and 2 feet deep is often plenty. It does not need to look pretty. It needs to be sound, dark, and easy to maintain. That box serves two purposes, and both matter. First, it catches the spring water as it seeps from the bank. Second, it acts as a settling chamber. That second part is where people get careless. If you let water run straight from the hillside into a pipe with no quiet chamber to slow down in, you carry grit, silt, and fine sediment directly into the rest of the system. Then, before long, you are fussing with clogged valves, dirty troughs, and lines that do not behave. A little calm water at the source saves a lot of aggravation downhill. The old systems understood that. They were not just capturing water, they were calming it. When you dig into the slope, keep going until you reach the wet layer itself. You will know it when the soil turns colder and darker, and then begins to gloss with water at the bottom of your cut. Once you find that layer, shape out a flat bench large enough for the box. The back of the box should sit right up against the live bank where the spring is entering. That matters more than people think. If you leave a loose gap behind the structure or build it too far out from the bank, the water can go around your work instead of through it. Water always prefers the easiest path. Your job is to make the box the easiest path. If you are using block, stack it the same sensible way you would build any simple retaining structure, with the joints staggered so the wall locks together. If you want permanence, you can mortar it. If you want easy access later, dry stacked block often works well enough when the bank itself is stable. But the back wall is different from the rest. The front and side walls are there to hold water in and keep contamination out. The back wall is where you want the spring to enter. That means you do not seal it tight and call that good. In fact, you want to encourage entry through that wall. This is where the old engineering trick really starts to show itself. Drill collection holes through the back course of block, or if you are using another material, create screened entry points that allow seep water to come into the box from the bankside. Angle the holes in a way that favors inward flow. It is a simple idea, but it is the difference between trapping water and merely walling off a wet place. The point is not to make the box waterproof on all sides. The point is to exclude dirt while welcoming water. That is what the system is doing at every step. It is sorting one from the other. Behind that back wall, build yourself a filtration zone with coarse gravel. Put landscape fabric, porous feed sack material, or another soil-separating layer against the wall first. Then backfill with clean drainage stone between the box and the bank. What that gives you is an artificial aquifer. Water can travel through the gravel freely, but fine particles are slowed and filtered before they ever reach your collection holes. Over time, that one layer does a great deal to keep the box clear and the water clean. And because it is buried and passive, people forget how important it is. But many long-lasting spring systems owe their good behavior to that quiet gravel filter no one sees once the job is finished. Then you need a lid. The lid matters for two reasons. It keeps contamination out, and it keeps light out. Leaves, insects, frogs, rodents, and surface wash have no business in your source box. Neither does sunlight. Light gives algae a reason to grow. A dark box stays cleaner. A piece of tin roofing weighted with stone works fine. Heavy planks can work if they shed water. Old metal lids, tank tops, and other salvage often work just as well. This is one of those jobs where farm practicality beats store-bought perfection. The lid does not need to look impressive. It needs to keep the box dark and protected. Now let me show you where the $12 claim actually lives, because this is the part that turns a wet patch into a controllable water system. The outlet assembly is cheap. A 3/4-inch pipe outlet through the front wall, a coupling, a short cleanout section, a threaded cap, and a little hydraulic cement or patch material around the penetration is often all the cash outlay the core trick requires if your box materials are salvaged. That is why this kind of system held on so long. The expense was never in understanding it. The expense came only if you insisted on buying everything new. The principle itself is almost free. The outlet should not sit on the bottom of the box. Put it a few inches up. About 4 inches is a good working rule. That lower space becomes your settling pocket. Silt and grit drop there. Water leaves from above it, cleaner and steadier. On the inside, give yourself a removable cap or short cleanout. So once or twice a year you can flush that sediment pocket without dismantling anything. That is another mark of old good design. A system meant to last is always built, so ordinary maintenance is quick. If maintenance is a misery, it gets postponed. When it gets postponed, small trouble becomes big trouble. Once the water leaves that outlet, gravity takes over. And that is the whole beauty of the system. If your spring box sits uphill from your stock tank, you already have your power source. No switch to fail, no bill, no pressure tank humming away in the background, just continuous flow. Now it may not be city pressure, but steady low-tech pressure is often more useful on a farm than people realize. With enough fall, you can run standard float valves, fill tanks, and supply multiple watering points. And because the water is available around the clock, the system does not need to move enormous volume all at once. It only needs to keep pace over the course of the day. For the distribution line, Black poly pipe is usually the practical choice. It is inexpensive, forgiving, and easy to run across long distances. If you live where winter has teeth, bury it below frost depth and save yourself grief later. If you lay it on the surface, you are volunteering for future problems unless your climate is mild and your setup is temporary. Keep the run falling naturally with the land if you can. Avoid creating places where the line dips and rises unnecessarily, because trapped air can stop a gravity system cold and make a perfectly good spring look like it has failed. If you have to cross awkward terrain, add a vent at the high point and a drain at the low point. Those little pieces of foresight pay back every winter, and every time the line needs service. At the far end, the simplest watering point is usually a stock tank with a float valve. As the animals drink, the water level drops, the float opens, and the spring line refills the tank. It is about as passive a system as you can ask for. No one has to remember to turn anything on. No one has to race home because the power blinked. No one has to hope a pump prime held. When stock need water, the tank refills, because the hillside is still doing what it was doing while you slept. That is why these systems earn such loyalty once people install them. They are not exciting, but they are deeply dependable. The next question is always the same. How much water can a spring like this really produce? Usually more than people expect. A spring that only seems modest when you look at it in a wet bank can produce thousands of gallons over a day, simply because it never stops. 2 gallons a minute sounds small until you remember that the minutes keep coming. That is why late summer testing matters. Take a known bucket, time the fill, and calculate your gallons per minute when conditions are dry and honest. That figure is your dependable baseline. Build around your minimum flow, not your best season bragging flow, and the system will treat you right. Water quality is the other thing a careful person should think about. Spring water often comes out cold and clear because the ground has already filtered it through layers of soil and stone. That is one reason people have trusted it for generations. But ground can add minerals, and uphill conditions can affect cleanliness too. Iron may stain orange. Sulfur may carry that rotten egg smell. Manganese can darken things. Livestock generally care less about those nuisances than people do. But if you are using the water for household purposes, or if the source lies below fields, septic influence, or runoff you do not control, testing is just good sense. Old methods are strongest when they are paired with honesty, not guesswork. One thing that unsettles people is when a spring seems to lose strength after several good years. But most of the time, the spring itself has not disappeared. The collection zone has changed. Fine sediment packs in. Roots creep into the gravel. The water finds an easier route around the box than through it. That is not the same thing as the source failing. It usually means the box needs attention. Dig out the gravel. Replace the separator layer if needed. Clean the backside, and restore the path into the collection chamber. In many cases, a half day of maintenance brings the flow right back. Springs are persistent. It is the structure around them that gets lazy. If the seam is broad, there is another trick that improves both flow and reliability. Use 2 collection boxes along the same seam instead of one. Space them apart and bring their outlet lines together downhill. That gives you redundancy and often better total yield because you are intercepting more of the water-bearing zone. If one box silts up or needs work, the other keeps the livestock watered. Old farm systems were often built by people who understood that reliability matters more than neatness. A little redundancy feels unnecessary only until the day it saves you. For a farm with several pastures, you can branch the line and serve more than one watering point. The key is to keep the main line large enough, and avoid choking your own pressure with pipe that is too small. A simple manifold with shutoff valves lets you direct water where you need it, isolate a section for repair, or shut off an unused pasture in winter. Again, no wizardry here, just thoughtful control added to a simple passive system. Now let me put some plain numbers on why this matters financially. The $12 part is the heart of the capture system, the fitting and outlet logic that makes the spring usable. But the real savings do not happen on day one. They happen every month afterward. No electric pump running, no pressure switch replacing, no tank cycling, no water dependence tied entirely to a powered system. Even if you spend real money on polypipe and a decent used tank, the total often comes in far below the cost of drilling, pumping, wiring, and maintaining a conventional setup. And once it is in, the operating cost drops nearly to nothing. The reliability may matter even more than the savings. I have seen plenty of farms get blindsided when a pump fails on a hot weekend or a power outage drags on longer than expected. Livestock do not care that the repairman cannot come until Monday. A gravity-fed spring line keeps flowing if the source is there and the line is sound. That kind of quiet dependability is hard to price until you have been on the wrong side of a breakdown and had to haul water instead of sleeping. There is also a property value argument here that practical buyers understand very well. A farm with a proven low-cost gravity water source is simply not the same asset as a farm that must lift every gallon mechanically. Water security changes how land is judged. A good spring is not a decorative feature. It is working infrastructure, and unlike many modern systems, it does not become more expensive every year just because time has passed. I also want to address the common objection that a person does not think they have a spring at all. Sometimes that is true, but many people simply have not learned to read their land. On hilly ground, hidden seams are common. Not all of them show obvious flow on the surface. That does not mean the water is not there. Look for the plant clues. Look for the persistent moisture line. Probe the soil. Compare what happens along a seam to what happens 10 feet away. Very often the farm is already telling you where the water runs. You just have to stop expecting it to wave a flag. And even a weak spring should not be dismissed too fast. A slow source paired with storage can still be very useful. If the spring drips steadily into a storage tank all night, it may give you more than enough water for the actual daily drinking period, even though the live flow seems unimpressive. That is another old practical lesson. Continuous low flow plus storage can outperform flashy high-demand systems people trust too much. Do not forget overflow. In wet periods, the box may collect more than your outlet is meant to carry. If you do not provide an overflow path, the water will make one, and it may wash around or under the structure. A high overflow line near the top of the box, leading away into a safe surface channel, prevents that trouble. Small detail, big difference. There is one more mistake that shows up again and again. People build the system, see it working, and then ignore it for years because it seems so dependable. Dependable does not mean invisible. Check the box a few times a year. Make sure the lid still protects it. Make sure the overflow is open. Flush the sediment pocket. Watch for roots and drifted soil. 5 minutes of inspection done on time will save hours of repair later. Season matters too. Most springs look strongest when the ground is fully charged and weakest at the end of the dry season. Design for the lean months. If late August flow supports your herd, then the rest of the year will feel easy. If you stock the farm based on the spring rush of wet season flow, dry weather may humble you. The land always has a truth level. Late summer is when water tends to tell it. Winter operation worries a lot of people, and rightly so. The spring box itself, buried into the hillside, is usually protected by the Earth's steady temperature. The places that fail are the exposed line and the exposed valve. Bury the line below frost if your climate demands it. Insulate or shield the float area from wind. Shut off and drain lines, feeding unused winter pasture. Water that moves below frost depth behaves much better than water left, sitting shallow and still. If you want a simple winter improvement that pays for itself, build a small insulated housing around the float valve area at the tank. That one little shelter often keeps the moving part of the system from freezing, even when ice starts forming on the open tank surface. It is not glamorous, but a lot of farm wisdom never is. There can also be a legal side depending on where you live. In many eastern areas, a spring on your own land used for ordinary agricultural purposes is straightforward. In some western states, water rights can be a different subject altogether. It costs very little to ask before you build. Better to know what your local rules are than assume every place handles spring water the same way. One of the greatest strengths of this old engineering trick is how valuable it becomes during emergencies. If the power goes out, many water systems stop at once. If public pressure drops, that tap at the barn may as well be decoration. A gravity spring line does not care whether the grid is behaving. As long as the hillside is holding water and the line is sound, the water keeps going. That makes the system more than a money saver. It makes it insurance. For farms that already have a well or rural supply, the smartest move is often not to replace those outright, but to pair them with the spring. Let the spring carry what it can carry. Keep the other source as backup. A couple of valves can give you two independent ways to water the farm. That is not extravagance. That is resilience. And if you want to extend the old principle even further, there is another layer beyond a simple downhill gravity line. A hydraulic ram pump can use falling water to push a smaller portion of that water uphill without electricity. That is not where I would start, and it is not needed for the core spring trick, but it belongs to the same family of thinking. Use water's own motion to do work before you reach for motors and monthly bills. So let me walk the whole thing back through plainly. Find the wet seam in late summer when the ground is honest. Go uphill from the visible seep and intercept the water before it spreads out. Build a covered collection box against the live bank. Let the spring enter through a filtered back wall. Put the outlet a few inches above the bottom so sediment can settle below it. Run your line downhill and let gravity carry the water. Protect the line from freezing, give excess flow an overflow path, and keep the system checked often enough that small problems never get the chance to grow up. That is the Amish engineering trick that actually works. It is not really about spending $12 and walking away with a miracle. It is about using $12 worth of fittings and 100 years worth of common sense to turn a wet hillside into a permanent water source. The larger system may cost more if you need line, tanks, and valves, and I would rather tell you that plainly than flatter you. But the trick itself, the part that makes the whole idea possible, is beautifully cheap. Modern farming pushes people toward dependence on things that break, bills that repeat, and systems too complicated to trust without outside help. This method leans in the opposite direction. One piece of good understanding, one sensible build, very few moving parts, very little to go wrong, and water that keeps showing up because the hillside has been making it long before you got there and will likely keep making it long after you are gone. If you have a wet place on your property you have been ignoring or cussing for years, stop and look at it with different eyes. That spot may not be a nuisance at all. It may be the beginning of the most dependable water system on your farm. Go walk the slope when the rest of the ground is dry. Notice what stays green. Notice what stays soft. Notice where the land keeps repeating itself. Free water rarely shouts. Most folks just never learned how to listen.